Welcome back. So today we're talking about power. Power is related to energy, but it is different. So power is how fast energy is being transferred or transformed. Another way of saying it is a rate of change, a rate of transfer, right? So we're going to define power as this capital P. Now, if you stick through Physics 1 and Physics 2, we're going to find there are a lot of P's floating around. But this is a capital P. A capital P, it's a little bit hard to see with this. I might even sometimes draw a little serif at the bottom. It's up to you how you want to delineate this variable. But I have power here. Power is going to be defined as dE dt. How fast is E changing in time? Now, more often than not, we'll probably just say delta E over delta T, and either talk about an average power or that the rate of change is constant, and so I can just talk about an easy to calculate P. Now, delta E is a stand-in for any energy. We could talk about the power of just about any energy here. But I want to talk about the units of power. The units of power, if we think about this expression right now, I have joules per second. This is actually going to give us a new unit called watts. All right, a joule per second is a watt. And we'll just label that as a big W. So if you ever heard of kilowatts, right, gigawatts, right, megawatts, any of that, it's all a term of power. How much energy per time is going through that system. I want to just explore one other way of talking about power, calculating power. If I think about dW is our force dot dx, right? I'm not integrating yet. I'm not talking about the full work. And I divide both sides by dt, right? And say dW dt. It's the change in work or change in time. That's going to be F dot dx dt. dx dt is our velocity, right? So really I have F dot v, or really dv, right? If I'm being serious about this a little bit. And so if I integrate this, right, integrate both sides, I'm going to get power, right, dw dt, dE dt, work and energy. The change in work is the change in energy of a system. So I have power here is equal to F dot V for our system. Another way of saying that, if I think about just the magnitudes of F and V times cosine and the angle between them, right, I can calculate the power of a system. I think this is actually a really useful expression, especially for a couple problems from the chapter. So keep this in your back pocket. We're not going to use this a whole lot. This expression that I'm underlining right now, what we're actually going to use is this definition a lot more. Just the straight up definition of dE dt is power. So that's power in a nutshell. I should have a few videos probably scattered throughout here, but a couple at the end now of example problems that we're going to work through. So take a look at that. Thanks for watching.